They used to say that. I'll say it. And we're back. What do you mean, and? All right, so let's talk. Now we know how it all works, and we got it all. Well, at least you're supposed to. Wait, we do? We know that? Let's talk about troubleshooting. Troubleshooting. All right, let's just say we have no or low voltage. So let me think. Talk about the aircraft now. Aircraft shows no or low voltage. So we're going to take a look at the ammeter. So if ammeter indicates a discharge, let's talk about what that means. I have an ammeter in the aircraft, and it always has like a 0 line. And then it goes, 5, 10, 20, and then 5, 10. Well, I guess there'd be 15 in there, but not always. 5, 10, 20. And so if I've got that, everything on this side is going to be positive, and everything on this side would be negative, which means everything on this side means charging. Charging, or to battery. And this side is from battery. From battery. So let's just say that I've got the landing light and the flat motor running and the gear motor running and the coffee maker running and the electric strip heater running and all of this stuff running, which is 30, 40 amps, but I've got my alternator generator is working just fine. Where would my needle be? Say we're pulling 20 amps. I got a 20 amp load on the aircraft. Generator's working fine. Where's my needle going to be? Right about there. Okay? Because it's what is going to the battery. Right? So very little. It's just a few amps goes to the battery. So everything's working fine. That's it is. Now, when I first start up the aircraft, so I've gotten in the aircraft, I've had the master on for a while, I've had the beacon running, the rotating beacon's been on. I hit the starter, I draw on that load, and then the generator comes on. What do I expect to see? Probably somewhere over here for a short period of time, and you can literally watch it just start working its way back to 0. So what's happening?
Running off the battery.
It's charging the battery. I used a heavy battery load. The battery is now discharged somewhat, not a lot. So as soon as the alternator generator comes online, you're going to watch that needle go back towards just the other side of 0. So it's going to always be on the positive side, because it should be, because the battery's always going to take a little current to keep it charged.
I find it too, Kevin, that you showed us when we were working with our gear motors.
Yeah.
That when you first energize that motor, it draws more amps in the very beginning.
Yeah.
Which would tend to drain that battery.
The starter. It's a dead short for a second. And so, yeah, it's going to come right back to 0. If you read the pilot operating handbook, I think, why would you do that? But I think the one I have now on my 150 said something about after how many minutes it should be 1 needle width away from 0. You had X number of minutes, and that should be there. It was indicating a normal charge. Now, what happens if I'm flying along and I look over and let me see if I can get rid of it. There, and my needle is kind of over here. That's bad. That's bad. Unless I'm flying it at something with a generator and I happen to be back at idle. That would be normal. So if I got a generator like in the Cessna 120s or 140s, and I'm flying at night and have landing and taxi light on, incandescent, they're not LED, and the nav light's on, and the coffee maker, and I pull back to idle, do I have a generator anymore?
No.
Coming in speed, boom, it's offline. What happened? Reverse current cutout opened up. It shut off the generator because the generator voltage dropped below the battery. And now what I'm showing is the load of the aircraft. This is how many amps are being pulled out of the battery. And then I add some throttle. Boom. It's going to do that. Charge that battery up. Slow. You can literally watch it start moving back to 0 because it doesn't take that long. Yeah.
So if you're coming down for landing, and you said reverse cutout, will it also still kind of cut over there if you've got like your lights and whatnot on still?
Say it again.
If you're coming in for like landing, you're
Yeah.
flying right, and reverse cutout, you said it's gonna cut it out. So will it go past there and start using the battery while like landing, since you still have like
Yes,
your lights? And
that's what I'm showing. When it was over in this area over here,
Yeah.
you're on battery only.
Okay.
You're limited.
So zero's charge, like even charging.
It means that when it hits zero, and it's always just a little bit to the positive of zero, it means you're trickle charging the battery. Even though it's,
Basically.
you're charging the battery. The rest of the load goes, so the ammeter, I have to say, really tells you what is going in or out of the battery. That's all it tells you. In the battery, out of the battery.
That makes sense.
Yes.
So is that why, I mean, this is probably not related, but is that why people turn, or pilots usually turn on the APU before they land? So they can use that auxiliary power unit instead of the battery?
That I don't know why they would do that, because there's plenty of generator in the other engines.
Well, that's what they used to do for landing the C-27.
Yeah.
When I was flying with them, they would turn on the APU right before landing.
Probably because they wanted the APU up and running so they could shut everything down and get to the beach quicker, as we'd say.
Probably.
So, whenever, I know you use your battery whenever your generator's not working. So it depletes the battery, which creates less resistance. And then whenever your generator kicks in, the current goes that way first, so that's why it charges.
Now, get rid of the resistance thought in your head.
Okay, so how come it knows to charge the battery? Like how
Because the battery's dead.
okay.
It's just that simple. So if you put X number of volts
Yeah.
towards a good battery, so let's just say I've got a 12 volt battery and I set it at 14.5 volts. If it's really a good charged battery, it's going to take less than an amp. It's just going to allow a little bit of trickle to go into it. But if I take that battery that's nearly dead and I set it for 14 volts, it'll take 10, 20, 30 amps, whatever it can take, because it's dead and the current flows real easy into the battery. At that point, I can think of resistance, but I don't want to. No. Okay. So what if the ammeter indicates a discharge? What are we going to do? What would you want to do?
Depends on what's going on.
Well, I'm just telling you, man. I'm a dumb pilot, as my friend Joe always says. I'm just a dumb pilot. And so I'm like, hey, man, I noticed that my ammeter indicates a discharge. When? All the time? Did you run it up? Yep. Did you get up past coming in speed? I don't know what that means, but I ran it up.
Is it okay? So it's up at cruise full power kind of.
Yep.
You got
So it
nothing.
just indicates a discharge all the time.
Something wrong with the volt regulator, man. No, or the
What do you-
coil.
What do you want to check? What do you want to check?
Could be the field.
Could be. What are you going to check?
Well,
See, now
let's check.
as mechanics, we can't. Well, could be the field. Could be the voltage regulator. Could be.
Throw these terms out.
You might have a spark tube that went out.
Right.
What's the easiest thing to check first?
I think it's the gimbal bearing.
Yeah.
That's right. So couldn't you just check the field to see if it maybe doesn't have continuity? Just
Maybe.
Grounded on the case.
Could it be the Russians?
Could be.
could be.
How about check the generator output?
Too obvious.
That's A plus.
That'd be the answer.
Now that's easier said than done. Where's the generator? On the engine. Where's the propeller? Right there. It's not a fun thing to do, but you can hook up alligator clips, wires, close the cowling, set up something so you can see it in a safe spot. Hey, check your. Is there anything coming out? Let's try that. Yeah, it's coming out. Okay, now we got some other things to think about. Just something to think about. All right.
Check your battery.
Let me see. What if? Let's say we have. You find out you have 2 to 6 volts. 2 to 6 volts on that output. Now, if I had 2 to 6 volts on the output, would you note it? Would you see anything on the ship's gauges?
You'd see it's discharged.
No.
You'd see it. That's
It would look like that. It would look like a discharge. Why?
because it's not up to what the batteries.
Right. Reverse current cutout's going to be
13.5.
So will the reverse current cutout be open or closed? Open. So the generator is not connected to the aircraft.
Right.
It's all right. I got 2 to 6 volts. What does that tell me?
Low output.
Yeah, low output. Very good. It's not wrong. It's not wrong at all.
Field coil would be bad.
He's not more right though.
Field coils. Why? So what is it telling me?
Something's not putting power into the field coil. Either the field coil's bad or
Why field coils?
because of, you got to put energy into the field coil to get big energy out.
Okay, so if it's 2 to 6 volts, I'm running on residual magnetism. So it's running on residual magnetism. So you got a field coil problem. So we're running on residual magnetism. That means no current in the field. Well, if I got no current in the field, that could be what? Okay. Voltage regulator. So we could say could be voltage regulator. That's very good. Survey says number 1 answer. Could be.
Current limiter?
No.
Current, the field
Can't be the current limiter. Well, current limiter, they don't really break to where they work better. It would be open and then it wouldn't have any effect. So I wouldn't say that because they're normally closed anyway.
Depending on if it's an A or B type, the field coil could be grounding or something like that.
Okay, field coil. Field coil could be open. Right, field coil, open. Voltage regulator, just bad. Could be anything. Points could be bad. The little itty bitty tiny wires that make up that coil, and they're very small. Could have vibrated and broke off. Mechanic could have put their fingers in there and touched it. What else do I got? Voltage regulator could be field coil. Yeah, we got that. Voltage regulator, got that. Could be some wire connections. Yeah, so you guys unfortunately have not, because, sorry, too damn slow, didn't get a chance to play with our brand new equipment across the way. That what do we call it? It's the whole aircraft simulator system for electronics, electricity system. Yeah, it's brand new. It's that's your last project on there, which I won't do. But anyway, yeah, I went to show Larry Papke how to work, and man, I hit the alternator on, and it just froze up the motor. I'm like, what the? And I'm like, well, I don't have time to deal with it now. And I was walking by Harry because Harry's kind of messed with it. And I'm like, oh man, that stupid thing broke. And Harry's like, well, show me. So I showed him, and I'm on one side where I have all the stuff, and Harry's like, I don't know. And he touched one thing, boom, it came on. He's like, oh, these 2 little wires just fell off and were grounding themselves out. So, that could happen. Could be, you wouldn't know this one, faulty.
And that's why our instrument landing systems work, because of error.
That's a fact.
You just gotta know where to hit it.
Faulty generator switch. In the aircraft, we have a dual switch. So one side is master and the other side is gen or alternator. Like in Cessna, you just usually hit them all at once. But a lot of aircraft have a master, and then once the engine's running, you pop on the generator switch. If we had no voltage, what could it be? No voltage out of the generator.
Something with the armature problem.
Something with the armature. Okay. Could be an armature failure. Probably not as likely, but it could be. I got 2 things up here. What do we need to get this thing going?
Ground?
Nope. Because if it's a B type, you certainly don't need a ground. It's already got one. Magnetism. lost residual magnetism, or you've got reverse polarity magnetism and it's not working well. That happens a lot.
Would you just lose magnetism by, let's say, it is
Sitting. Sitting for a long time, you sure could.
Is that what you're talking about sending them to the shop? Because the polarity was.
Yeah, it's, well, yeah. One of the things that you're doing too, when you test them, like you're going to do this. You have the growler, you're testing it, and you have these little probes. That's AC. What do you do when you run AC through a coil next to a piece of metal? You kill the magnetism out of it. So you do enough AC on there, it's going to scramble it, and you're going to lose your magnetism. Run battery power through it the wrong way, you're going to reverse, the north and the south get reversed. So Phil told me that along this line, the most interesting thing the other day, I had no freaking idea. That, you know that the Earth magnetism changes? Well, we kind of all know that, and you think about it, but he was telling me that if you've lived long enough, and he says he has, he remembers when this runway out here, it's 1.6 and 3.4. He remembers when it used to be 1.5, and the reciprocal for 1.5.
SMF just changed. It was 1634. Now
Yeah.
it's 735.
Yeah, SMF. They just changed theirs because the runways are magnetic to the nearest 10 degrees. And so as the magnetism changes, you change the runway numbers. I'm like, yeah. Yeah. So his point was if you've seen two runway changes in your life, you're an old person. And you've been in aviation a long time. So, it just blew my mind. All right, you could have lost your residual magnetism, or let's think about what's the number one wear item in a generator. All right, brush failure. Those are the most likely. All right. If you have nothing, yeah. It's a wear item. One of the things you can do, you have to be careful with it, is you can bypass the regulator. That's what I just told you. Some of these things are a really good way to ruin a voltage regulator. And all right, lessons learned. I don't do anything with a voltage regulator connected. Those wires are so freaking tiny, it takes almost nothing to destroy them. And I've seen so many mechanics destroy them. And to the point where it's like, you know, kind of screwed it up. So when a voltage regulator, especially these non-solid state vibrating type are connected, I don't touch nothing, right? You can flash the field, but I'm really hesitant to do that, and I'll talk about that. And it doesn't. Oh, so, but regulator, bypass the regulator. I'll do that with you guys on the test stand. I have no problem, and I'll actually do it with the regulator attached. So I guess I will do it because I know it won't hurt it. But bypass the regulator. If you have, let's see, what do I say? I'll put voltage. Bypass the voltage regulator. So if you have an A-type, connect F to ground very quickly. Tap it as fast as you can, and you will be absolutely shocked at how much the output will just jump up. And if it does that, you know you don't have a generator problem. If B-type, connect F to A very quickly. And again, you will see max output very fast. So you can bypass the regulator, and then if you get on an output, on a large output, the generator's okay. There's no problem with the generator. It's doing what it should. And that means the generator's okay, so it must be the voltage regulator. Must be the voltage regulator. If the output does not increase, then it's the generator. So then we have flashing the field. All right, so generators can lose their magnetism. Generators can lose residual magnetism. And as I explained the other day, generators are self-exciting. Doesn't matter if you have a battery or not. If you don't have residual magnetism, you get no generator. Generator first develops its own voltage, then builds up, then turns on the voltage regulator. Right? Other systems like an alternator, it's the opposite. You need a battery in order to get the alternator going. But generators can lose residual magnetism. If it loses its magnetism, it's not coming on. You can spin it as fast as you want. It's not going to work. There's nothing there. There's no magnetism to make it work. So then what you have to do is you have to then flash the field, which is putting current through the field coils in the proper direction, in the proper way, so that that current going through the field coils is an electromagnet, which then energizes the pole shoes, which causes it to then have residual magnetism. So you can lose magnetism. Magnetism can get reversed. To correct this, you can flash the field. All right. I'm just going to put this. Follow the manual. I don't even want to tell you how to do it. That's how I've seen people ruin more voltage regulators than not. My notes I put simply disconnect the voltage regulator and apply the correct polarity voltage to the generator. I'll say follow the manual. This does not involve untucking your shirt.
Trench coat.
There's no trench coat action here. Scared into working. Yes.
What do you mean by reverse magnetism can get reversed?
North is south and south is north.
Okay.
And then if you do the left-hand rule of thumb, you know that it goes the wrong way. Maintenance, maintenance. All right. Put my DME hat on. One of the projects that you will be asked to do, or were asked to do when I was a mechanic examiner, that was on my official FAA list of projects to ask you, was to inspect an engine-driven generator. What are you going to do if somebody says, inspect an engine-driven generator?
Look for cracks, corrosion, and leaks.
He's got it. That's what I wanted to hear.
Yes.
You only missed one thing.
Put on the brakes.
Say again?
You only missed one thing.
If it's theirs,
Security.
security. Yeah, you gotta make
Bolt-
sure it's
bolted
bolted
on.
there, yeah.
Yeah, bolted on. Make sure it's bolted on. So, I don't want to take a bunch of time. So inspect the flange for cracks, oil leaking from the generator. I could write some of this stuff. So cracks, oil leaks, because it is Continental more than Lycoming is attached to the engine. It's internally driven, so it has to bolt to the engine. You have to have an oil seal, and if the oil seal fails, then you get oil splashed in the generator. You got oil leaking out the back of the generator, and you don't want to say something like, well, it looks like we need to change the oil in the generator. No, it's not supposed to.
Generator oil bad.
Yeah, oil leaks. Let me see, where was it here? Inspection, oil leaks. Yeah, so engine oil coming from a bad seal could do it. Brush wear. What's the maximum that can be worn?
50%.
Okay, 50%. How do you know if it's 50%?
Lines.
A wear mark. If there's no wear mark, then
You get a new one.
Probably past 50%.
it's past the wear mark, or you get a new one and find out. All right. Let me see. Check the brush spring.
Is it better just to assume that it's past 50% if you don't see it?
No, not if I'm paying you. Don't assume that. there's a spring that pushes down on the brush that runs on the commutator. You want to make sure that that spring tension is good if in question. You want to check the commutator for arcing, wear. I could put that for wear. And you want to check the mica. M-I-C-A, mica. Mica is an insulating thing. Now, you know in the commutator, looking at the end, you have all these little segments that go around. Well, they can't touch each other, so in between there, they put an insulator, and that's called mica. And the mica has to be undercut. So what you do is when you start to get wear on your commutator, you put it in a lathe. And you shave this whole commutator down so the whole thing is very smooth and perfect. But then the mica is at the exact same height as the commutators. And you want that mica undercut. So then you get in there with an undercut machine and you undercut it about a little bit all the way down so that the mica is down below the surface.
Have you had to do that?
What?
Have you had to do
Oh, yeah, I've done it. Yeah.
There's a machine for it?
Yeah, we have one here. I can show it to you.
Oh, the book said a hacksaw. Or,
No, it says for hacksaw for something else. Yeah, inspect the terminals. Oh yeah, terminals. Why don't I write that? So inspect the terminals. I'll warn you now. Well, I'm not here. I guess it's Larry, so I don't have to warn you. But if you were doing the generator project with me and you hook the generator up and you see the instructions that said hook it up in an airworthy manner, first thing I do is I walk up and I see, did you just put stuff on finger tight? If you put stuff on finger tight, I'm just going to say, well, if that's the way you're going to do it on an airplane too. That's just a really bad grade. So don't be in that habit. You know, it's the habits you're in. So if you're in the habit of putting terminals, you know, the wires onto the A positive and the field, if you're in the habit of putting them on around a shop and just running them finger tight going, I don't have a wrench, then that's the same habit you're going to carry off to an airplane. So don't do it. You know, I would never, working on an airplane, take the terminals, put them on a generator, put them on finger tight, say look good, and then go, well, I'll go get a wrench. Because on the way to get a wrench, guess what? Somebody goes, hey, it's break time, or help me with this, or, you know, we got to push this airplane out. And then before you know it, you're like, oh, what was I doing over there? Oh, I got the generator hooked up. All right, next. You guys, I told you about listening to that podcast, There I Was. So, yeah, you guys enjoying that? Yeah. There's one guy who, I forget the whole story, but it was complete electrical failure at night in an aircraft they think that had electrical landing gear. Complete and total electrical failure. No moon, no light. I mean, it's, you know, I learned a lot about that one, about what to carry with me at night. You know, thanks to that one, I actually put a little headlamp on that you know, I can turn on in case of emergency, see my stuff. Whole thing ended up because somebody didn't tighten the battery cable. That's all it was. Ground cable was hand tight, bounced off, complete electrical failure, you know, almost killed him, ruined the plane. Something that simple. So make sure when you put stuff on, all the way. So.
You said in 309 that if you get stopped, go back 3 steps.
Yeah, it's easy to say that, but it's in practice, it's not practical.
Yeah.
Because you don't even remember your steps. You're like, where was I? See, I was doing the generator. You know, you just don't. You know, you're supposed to, but.
I didn't remember you saying never put anything on unless you're putting it on final, like fuel
Yep.
light or something. Unless you're ready to crank it down, like do not put it on.
Don't put it on. Yep. Especially hoses. That's my big thing, hoses.
Usually I red tag my stuff. Like say if I'm about to step off,
Yep.
I have like in my bag a little red tape.
Yeah, it's a good one.
Just tape it off, just to be like, okay, why is this tape here?
Yep. That's stuff like that is perfect. It's just a big flag of some sort. I was here. You know, even if you were, you know, just develop habits. What do I have? Terminals. I think I lost my paper. Oh yeah. Check for Michael. Over here. Yeah, terminals for tightness, belt tension. Let's see. I've got a bunch of stuff here about overhaul. Growler. Have you guys watched the Vidya?
Yes.
No.
All right,
Video at one time.
this one.
No.
Well, you're in for a treat then.
No, fun.
Lights?
Camera?
It's an obnoxious. Okay, so this is a growler. This is a great video. I really appreciate the guy that did this. I have to, I think, turn off the recording though because it will violate the terms of. Yeah.